So anytime you start to talk about thermodynamics, you must consider the system and the surroundings. So recalling from previous lectures, you'll recall that the system is the part of the universe that's being studied, whereas the surroundings, the rest of the universe that interacts with the system. Today we're going to focus on three different systems. The first system is an open system. An open system is one that will exchange energy and matter with its surroundings. So what I mean by that is if you consider boiling a beaker of water, okay, in this case, energy is going to be transferred to and from the beaker, but we'll also have matter that is allowed to enter and escape. So that's an example of an open system. The next type of a system is a closed system. And whenever you start to look at a closed system is one that only exchanges energy. So an example of that would be a pressure cooker. So if you were to look at a pressure cooker, we're not letting matter get into or out of our system. We're only letting energy be transferred between the two. Okay, so between the system and the surroundings, energy is transferred, but the matter is not allowed to escape. And finally, the last type of system that we will look at is more of a theoretical system, but we can think about a few examples on smaller time steps. And this would be an isolated system. And in an isolated system, there is no exchange of energy or matter. So we can almost think about our system as being isolated in this bubble. So a good idea to think about this would be to consider one of the Yeti thermoses or like a hydro flask, something like that with a lid. And if you were to look at a small enough time sample, what you'll see is there is minimal energy lost to the surroundings. In fact, if we look at a small enough time step, it's essentially zero. Now, over time, we know that that's not true, but we tend to look at and consider things in thermodynamics as isolated systems, kind of as a proof of concept. So I hope today now you can explain the difference between an open system, a closed system, and an isolated system.